we had ended the last one by qualitatively describing what happens when k vector lies in the x1 x3 plane. I wrote it as k epsilon 3 cos theta plus epsilon 1 sin theta. Let's do the mathematical calculation in a little more detail. Now we have here V1 equal to V2 equal to VO, and V3 is equal to VE. We also have equation 5 of the notes I had sent, which is the following: K1 cap squared divided by Vp squared minus V1 squared plus K2 cap squared divided by Vp squared minus V2 squared plus K3 cap squared Vp squared minus V3 squared equal to 0. We will assume here Vp that I have a solution of this equation is not equal to Ve, or Vp is not equal to Vo. Okay. So here notice there is no K2, K2 is 0. So I have only these two terms. I can cross multiply and write down for K1 K sin theta and cos theta. So you will just get, I will write down for Vp, Vp double prime squared minus V3 is Ve squared, and for K1 it is sin squared theta plus Vp double prime squared minus Vo squared cos squared theta equal to 0. So from here I can immediately get my Vp prime. So Vp prime squared equal to Ve squared sin squared theta plus Vo squared cos squared theta. Or Vp, and remember I can write for these expressions Vo is nothing but C by No. Ve is C by Ne. So I can rewrite this equation in the following form, writing Vp prime as C by N theta. I will write this as 1 by N squared theta equal to, this is C squared, I will cancel C squared everywhere. I will write this as 1 by Ne squared sin squared theta plus 1 by No squared cos squared theta. This is the standard form in which this equation is written. And Vp double prime from here is nothing but C divided by N theta. Okay. Let's just write down some numerical values for Vo and Ve coming from No and Ne, so that you get a feel for what they are. That will be the next thing I will do. So I have here for quartz Ne is 1.553 and No is 1.544, and so Ve you can calculate, it comes to 1.932 into 10 to the 8 meters per second, and Vo we will calculate is 1.943 times 10 to the 8 meters per second. Notice VO is greater than VE, and that's for a positive crystal. So this gives you an idea of how the velocity change occurs. It's not very much, but enough to make physical observations. Okay. Now we proceed to analyze the d vector and E vector for the k lying in the epsilon 1, epsilon 3 plane. We have the following equations. D is one possibility is epsilon 2 E1. Why? Because k is in the 1, 3 plane and D must be orthogonal to k vector, and one such vector is the one which I am writing, sorry, or D. This is acceptable, and normally this is called D1. And what about its velocity associated with it will be Vp prime will be the vector pointing along epsilon 2. There the dielectric constant is epsilon 2, and so Vp prime will be NO. Now let's go to D2, which is orthogonal to k. Remember, my k vector was k times cos theta plus epsilon 3 plus sin theta epsilon 1, and that now D2 will be perpendicular to it, so I will write D2 times minus sin theta epsilon 3 plus cos theta epsilon 1. That makes it perpendicular. But what about E2? E2 would be D2. Here I will write minus sin theta by epsilon 3 cap plus cos theta by epsilon 1 cap divided by, to make this a unit vector, I will make it as sin squared theta by epsilon 3 squared plus cos squared theta by D2. So I should write this as E2. Correct? Cos squared theta by epsilon squared. This is a unit vector, and that's the magnitude associated with it. The direction of it is just by dividing by epsilon 3 and divide by 1, and that of course to the power half. Now let's calculate the angle between D2 and E2. If that is nothing but, this is a unit vector, this is a unit vector. So if the angle, if I write D2 dot E2 as equal to D2 E2 cosine alpha, I get cos alpha equal to, I multiply these, I get sin squared theta by epsilon 3 plus cos squared theta by epsilon 1 divided by sin squared theta by epsilon 3 squared plus cos squared theta by epsilon 1 squared to the power half. So since D2 and E2 are not parallel to each other, the ray, K ray, will make an angle with respect to K alpha. That is, I have my D, say this is my K, and my D is in that direction, say D is in that direction, which I am say this is my epsilon 3 and this was my angle theta, and D is in that direction. E is in the direction which is like this. This will be my D, this will be my E. Notice the component along epsilon 3 is a little less, so I should write it the other way around, sorry. So this will be little less, and how should I do this? Okay, epsilon 1 by epsilon 3. How should I do this? Let's just see. I put that there. Epsilon 1 is less than epsilon 3. So this is less than 1, and so it will be in that direction. It will be, this is the direction, that will be the direction of E. D is here, E is here, and my K ray will be perpendicular. This is my K ray, and this is my K, and this angle will be alpha. This angle is alpha. So it will be in a direction which, have I moved it wrong? I moved it too much, the wrong side. Excuse me. It should be here. D. My diagram is poor, so let me redraw that. My E is in that direction, epsilon 3, and my K is in that direction. I should draw this perpendicular. This is my D, and my E, let me draw E with a different colored pen. I will draw it with a red pen. That's my E, and this will be the direction of K ray, and the other one was the direction of K. Okay. This angle is alpha, this angle is alpha.